On April 6, 2026, at 6:44 in the evening, Eastern Time, 4 human beings vanished from the rest of the species. Not figuratively, completely. NASA's Orion spacecraft, callsign Integrity, slipped behind the far side of the moon, and for the next 40 minutes, every radio channel between Reed Wiseman, Victor Glover, Christina Koch, Jeremy Hansen, and the entire population of Earth went dead silent. No signal in, no signal out. No mission control able to help if anything went wrong. No human being in history had ever been this physically isolated from every other living person on the planet. No spacecraft carrying a living crew had ever traveled this deep into the dark side of another world. No mission control room on Earth had a single working channel to reach them. No backup relay, no way to intervene. No human eyes had watched that particular stretch of lunar terrain, lit and alive, in over half a century. And somewhere in the middle of that blackout, with no cameras rolling that could reliably catch it, and no way to radio home about it in real time, the crew looked out their windows at a hemisphere of the moon no human eyes had watched in 54 years, and saw something flicker. It is not a photograph. It is not a sensor reading. It is 4 trained astronauts with their own unaided eyes, watching the moon's hidden face light up in ways nobody entirely expected, and nobody has fully explained since. Stay with me, because what they actually witnessed, and how much scientists still don't agree on about it, is a stranger story than the headlines let on. If you're new here, this channel breaks down real space missions in plain language. No filler, no science fiction, just what actually happened and what we still don't know. So if that sounds like your thing, the subscribe button is right there and it's free. Let us go back to the beginning. Artemis II was never supposed to be a simple sequel. NASA's return to crewed lunar spaceflight had been building since Artemis the Wormstorm, an uncrewed test flight launched in November 2022 that sent an empty Orion capsule around the moon and back, proving the hardware could survive the trip before anyone risked a human life on it. That caution made sense. Nobody had flown a new deep space capsule with astronauts aboard since the space shuttle era ended, and nobody had sent people past low Earth orbit at all since the last Apollo mission splashed down in December 1972. The Space Launch System rocket and the Orion capsule represented the first genuinely new American vehicle built specifically to carry humans. Beyond Earth orbit in half a century, and half a century is a long time for institutional memory to fade. Engineers weren't reinventing rocket science from scratch, but they were relearning, in exhaustive detail, everything the Apollo generation once knew about keeping fragile human bodies alive that far from home. Here's the number that matters for everything that follows. Apollo 13, in April of 1970, holds the previous record for the farthest any human being had ever traveled from Earth. 655 miles, reached not by design, but by the detour a damaged spacecraft was forced to take around the moon on its way back to safety. That record stood for 56 years. Artemis II was built from the outset to beat it, deliberately this time, and by design. And here's the piece of context that matters just as much. While several Apollo crews did fly around the moon and glimpse its hidden hemisphere with their own eyes between 1968 and 1972, nobody had made that same trip in 54 years, and nobody in the history of spaceflight had ever specifically watched that far side for signs of life. Meteoroid impacts. Ground telescopes on Earth have monitored the moon's near side for exactly this kind of flash for decades, because the near side is the only side we can ever actually see from home. The far side is permanently turned away from Earth by tidal locking. It never faces us, not once in the entire history of the moon's orbit, which means, until April 2026, whatever was hitting that hidden hemisphere had never once been observed by anyone. The vehicle itself deserves a moment of explanation because none of what follows makes sense without it. Orion is a roughly cone-shaped crew capsule built by Lockheed Martin with a European-built service module supplying power and propulsion, a genuinely international spacecraft in a way Apollo never was. It launches on the Space Launch System, an enormous rocket, assembled specifically because nothing else in America's current fleet is powerful enough to send a crew capsule, its life support, and enough fuel for a lunar trip in a single launch. Getting SLS and Orion to this point took the better part of 2 decades and tens of billions of dollars. And it's worth acknowledging plainly why that timeline was defensible rather than wasteful. Crude, deep space hardware has to survive radiation. Exposure, temperature extremes, and multi-day life support demands that low Earth orbit vehicles like the Space Shuttle or the Dragon capsule were never designed to handle, and there was no shortcut around testing every one of those systems exhaustively before putting people inside. Artemis II's entire 10-day flight plan, launch, a long elliptical loop around Earth to test systems, translunar injection, the flyby itself, and a 4-day trip home, existed specifically to validate all of that before Artemis III and Iphigenia asked the same hardware to support a landing. The crew itself was chosen with just as much deliberation as the hardware. Commander Reed Wiseman and mission specialist Christina Koch had each already logged more than 160 consecutive days aboard the International Space Station. Koch's prior spaceflight, in fact, still stands as the longest single stretch any woman has ever spent off Earth. Pilot Victor Glover brought his own. Veteran ISS experience and mission specialist Jeremy Hansen, representing the Canadian Space Agency, became the first person from a country other than the United States ever to fly beyond low Earth orbit. None of that experience was decorative. Every one of them had already proven they could function calmly and competently in an environment with no easy way home, which is exactly the skill set a 40-minute total blackout behind an alien world was about to demand of them. The Farside flyby was scheduled for Flight Day 6. At 9:41 a.m. Eastern, Orion crossed into the moon's gravitational sphere of influence, 41,072 miles out. By 10:56 a.m., the crew had already broken Apollo 13's 56-year-old distance record, with Mission Control watching the milestone tick past in real time. Then, at 6:44 p.m., Orion slipped behind the moon and the 40-minute blackout began. During that window hidden from Earth entirely, the spacecraft made its closest approach to the lunar surface, about 4,067 miles up, at 7:46 p.m., and 2 minutes later reached its absolute peak distance from Earth. 252 for now 756 miles, roughly 400 miles beyond where Apollo 13 had gotten. I read that again. The single farthest any human being has ever been from home happened while every radio on the spacecraft was completely dark, with no one on Earth able to see it happen live. And it was during that same stretch of total isolation, staring out at a hemisphere of cratered, sunlit terrain never directly observed by human eyes before, that the crew reported something nobody had specifically been looking for. What they saw were meteoroid impact flashes, sudden brief bursts of light produced when a small chunk of rock or dust, sometimes no larger than a grain of sand, slams into the lunar surface at speeds that can exceed 10 miles per second. The moon has no atmosphere to burn these objects up the way Earth's does, so instead of a harmless streak of light high overhead, the impact happens directly on the ground, releasing its kinetic energy in a flash of heat and light lasting a fraction of a second. This isn't a new phenomenon in general. Scientists have used ground-based telescopes to catch impact flashes on the moon's near side since a NASA-sponsored monitoring program began in the mid-2000s, cataloging hundreds of them over the years, patiently building a statistical picture of how often small objects strike the near side and how bright those strikes tend to be. That program made complete sense as a way to study the phenomenon, given the tools available. A telescope on Earth can only ever point at the hemisphere facing it, and it can only watch for the sliver of time each month when that hemisphere's night side is both dark enough and geometrically visible to catch a faint flash. Every one of those. Limitations meant the far side had simply never been part of the dataset. Not because scientists lacked interest, but because the moon's tidal lock made it physically impossible to observe from anywhere on or near Earth. What was new on April 6, 2026 was location. The crew reported 6 separate flashes on the far side over the course of their flyby. Brief, sudden bursts that astronaut Victor Glover and his crewmates described as resembling tiny lightning strikes, or sparks flaring and vanishing almost before the eye could register them. Translate that to something you can actually picture. Each flash likely lasted a small fraction of a second, roughly comparable to the duration of a single camera flash going off in a dark room, except from a vantage point thousands of miles away and moving at over 3,000 miles an hour. Here's where it gets stranger. According to Kelsey Young, NASA's Artemis II lunar science lead, capturing these flashes on camera is notoriously difficult. The events are simply too brief, too faint, and too unpredictable for automated equipment to reliably catch. The unaided human eye, trained and attentive, outperformed the cameras. Sit with that for a second. In an era when robotic probes and orbiting telescopes routinely outclass human perception, it was a person looking out a window, not an instrument, that made the observation possible at all. Here is where this stops being an abstract curiosity about rocks hitting rocks. Every one of those flashes represents a real physical impact, a fast-moving object striking a surface with enough energy to gouge a crater and vaporize material on contact. NASA is not tracking these events for the sake of trivia. The agency is actively planning Artemis Base Camp, a permanent human outpost near the moon's south pole, and a 2025 MIT-led study specifically flagged micrometeoroid impacts, alongside radiation and extreme temperature swings, as a hazard that has to be engineered around before anyone lives on the lunar surface for months at a time. Every impact flash the Artemis II crew witnessed is, in effect, a live data point about how often the ground beneath a future habitat gets struck, and how hard. This is not a story about lights in the dark for their own sake. It's a story about the difference between a well-protected home on another world and a very expensive mistake. A habitat wall, a spacesuit fabric, a solar panel, a water storage tank, Every one of those has to be engineered against an impact rate that, until April 2026, nobody had ever measured directly on the far side, where NASA's own South Pole outpost plans are increasingly concentrated. The gap between "we think this happened sometimes" and "we watched it happen with our own eyes 6 times in 6 hours" is the gap between an engineering assumption and an engineering requirement. But before any of that data made it back to Earth, the crew had to survive the blackout itself, and that 40 minutes carried its own quiet tension. Losing radio contact with the ground wasn't a malfunction. It was expected, planned for, built into the mission timeline months in advance, a simple consequence of the moon's solid bulk physically blocking every line of sight signal between Orion and NASA's antennas back home. But expected and comfortable are not the same thing. For 40 uninterrupted minutes, if anything had gone wrong on that spacecraft, a system failure, a medical emergency, a navigational error on the precisely calculated free return trajectory that was the only thing guaranteeing their safe path back to Earth. There was no one to call, no ground controller to consult, no possibility of real-time help of any kind, and the crew was flying entirely on pre-programmed guidance and their own trained judgment, alone behind 250,000 miles of rock and vacuum. When President Trump later asked pilot Victor Glover how it felt when communications cut off, Glover's answer was simple. "I said a little prayer, but then I had to keep rolling." That's the whole crisis in one sentence. Genuine uncertainty, acknowledged honestly, followed immediately by the discipline to keep functioning anyway. This is the part that separates a lunar flyby from almost any other kind of human spaceflight risk. On the International Space Station, a communications dropout might last minutes and resolve itself as the station's orbit carries it back into range of a ground station or relay satellite. Here, the blackout was total by design, driven by the unmovable geometry of a 250,000-mile trip, with no relay satellite anywhere nearby to bridge the gap. The free return trajectory Orion was flying, a carefully shaped path that uses the moon's own gravity to curve the spacecraft back toward Earth, even with no further engine burns, was the one thing standing between the crew and a stranded, powerless drift through deep space if something catastrophic had happened during those 40 minutes. It had been calculated, checked, and rechecked for years before launch, specifically so that human intervention wouldn't be required to bring the crew home even in a worst-case failure. On the ground, engineers at Johnson Space Center in Houston could do nothing but wait, watching a countdown clock tick toward the moment Orion was calculated to re-emerge from behind the moon, and, if everything had gone according to plan, re-establish contact. At 7:24 p.m. Eastern, it did. Christina Koch's first words back on the line were simple and unguarded. It was, she said, so great to hear from Earth again. 40 minutes of engineered silence, resolved by nothing more dramatic than physics working exactly as predicted, which, when the stakes are 4 human lives 250,000 miles from help, is its own kind of triumph. Here's what is happening right now, in 2026. Artemis II splashed down safely off the coast of San Diego on April 10th, closing out a 10-day mission that met every one of its major objectives. In the weeks that followed, NASA released more than 12,000 raw, unedited images from the flight through its public gateway to Astronaut Photography Archive, the largest single collection of crude lunar photography since the Apollo program ended. Shot on a mix of Nikon D5 and Z9 cameras alongside consumer iPhones, the crew carried for casual documentation. Scientists are now combing through that entire archive, cross-referencing crew observation logs against every frame, trying to determine whether any camera on board caught even a partial trace of the same flashes the astronauts saw with their own eyes. As of this year, researchers have floated several competing physical explanations for exactly what produced those bursts of light, and, this is the honest part, the part that doesn't wrap up neatly, no single explanation has been confirmed as the answer. What most people are not seeing when this story gets summarized online is that the crew saw something we can't fully explain yet is not a headline exaggeration. It is the literal current state of the science. Just this month, NASA has continued releasing updates on the broader Artemis III preparation effort, including, as recently as mid-July, an announcement that imagery downlink for the next crewed mission will route through SpaceX's Starlink network, a sign of just how fast the ground infrastructure supporting these flights keeps evolving, even while the far-side flash question from Artemis II remains open. According to NASA's own public science lead on the mission, the priority now is comparing the astronauts' verbal timestamps and hand-drawn sketches, made in the minutes immediately after each flash, against every available camera frame from that same window, in the hope that even a single accidental capture might exist somewhere in the archive. None of the 3 leading explanations are exotic or fringe. Each one is grounded in physics. Scientists already understand reasonably well elsewhere. What's unresolved isn't the underlying science, it's which mechanism, or combination of mechanisms, actually produced this specific set of 6 observations, made by untrained for this exact task human observers, under conditions no instrument had ever recorded before. The leading candidate is straightforward. High-speed micrometeoroid impacts, the same basic mechanism that has been producing documented flashes on the moon's near side for 2 decades, simply occurring, for the first time, somewhere a human being happened to be watching. But it isn't the only idea on the table. A second hypothesis involves the moon's surface dust itself, fine, electrically insulating regolith that can build up a static charge under constant bombardment by solar radiation and cosmic rays, potentially discharging in small, sudden sparks, not unlike miniature lightning. A third possibility points not at the moon at all, but at the spacecraft and its occupants. Cosmic rays, high-energy particles from deep space, are known to occasionally strike the human eye directly, producing a flash of light perceived even with the eyes closed. A phenomenon astronauts aboard the International Space Station have reported for years. It's possible some portion of what the Artemis II crew saw wasn't happening on the moon's surface at all, but inside their own retinas. Scientists studying the observations have not ruled any of these 3 explanations out, and it is entirely possible more than one of them is true simultaneously, layered on top of each other in the same 40-minute window. Any of these ideas could turn out to be correct. Right now, nobody knows which one is. Zoom out from the flashes themselves, and there's a pattern here worth sitting with. The story of Artemis II breaking a 56-year-old distance record was always going to make headlines. It's clean, countable, easy to verify. But the more interesting discovery came from something nobody put on the mission's official list of objectives. 4 trained observers, alone in the dark, noticing something a machine was specifically bad at catching. This is, in miniature, the entire argument for sending humans instead of only robots deeper into space. Robotic missions are extraordinary at doing exactly what they were built to do, with precision no human hand can match. But they are, almost by definition, bad at noticing what nobody thought to program them to look for. A camera has to be aimed, timed, and triggered by someone who already knows roughly what they're hunting. A human eye, attached to a curious mind with nowhere else to look, just watches. And sometimes that's the difference between a phenomenon going undocumented for another 50 years and a phenomenon finally getting recorded, however imperfectly, by 4 people who happen to be looking out the right window at the right second. Think about what that means for every debate about whether crewed spaceflight is still worth its enormous cost compared to sending robots alone. The strongest argument was never that humans are more precise instruments than machines. They aren't, and building an argument on that premise would lose immediately. The strongest argument is that humans notice the thing nobody thought to ask a machine to look for in the first place, and then come home and describe it in enough plain, ordinary language that scientists on the ground know exactly what question to start investigating next. NASA's own next steps make that argument concrete. NASA's currently stated target has Artemis III launching no earlier than late 2027, not to land on the moon, but to test docking and rendezvous procedures with the SpaceX and Blue Origin lunar landers in Earth orbit first, a deliberate, cautious dress rehearsal before anyone rides one of those landers down to the lunar surface. Artemis IV, targeted for early 2028, is now positioned to be the mission that finally puts American boots back on the moon for the first time since 1972. Every one of those missions will carry more human eyes back toward that same unexplained hemisphere, and every one of them is a further opportunity to finally settle a question this crew accidentally opened and nobody has yet closed. There's a particular image from that flyby worth holding on to after the facts fade. As Orion approached the far side, the crew watched Earth, the only home any of them, or any human being who has ever lived, has ever known, shrink to the size of a basketball, and then slip entirely out of view behind the curve of another world, vanishing the way it had for no living astronaut in 54 years. For 40 minutes, that basketball-sized planet carrying every person any of them had ever loved was simply gone from the sky, replaced by an alien, cratered horizon lit only by reflected sunlight, and, occasionally, by something briefly and silently igniting on the ground below. Christina Koch would later describe one of her most unforgettable moments of the entire mission as the instant Earth reappeared, the first glimpse of home swinging back into view after that stretch of total isolation. Somewhere in the 12,000 raw frames NASA has released sits a photograph of that exact reemergence, a thin blue arc rising back over a gray alien horizon, 4 human beings watching their entire world return to the sky, 1 frame at a time, 40 minutes after it had disappeared into the dark. Somewhere in those same 40 minutes, unrecorded by any of those cameras, is the exact instant one of 6 brief flashes lit up a crater nobody on Earth has ever named, watched by eyes that had never expected to see it, and then vanished before anyone could turn a lens toward it. Both moments happened in the same silence. Only one of them left a picture behind. So here's everything in one breath. On April 6, 2026, The Artemis II crew flew behind the moon's far side, breaking Apollo 13's 56-year distance record at 656 miles from Earth, all while enduring a 40-minute total communications blackout with no possibility of help from the ground. During that blackout, they became the first humans ever to specifically watch the lunar far side for signs of live meteoroid strikes, and reported 6 distinct impact flashes. Brief, sudden bursts of light that NASA's own science lead says are notoriously difficult for cameras to catch at all. The mission splashed down safely on April 10th, and scientists are still combing through the resulting 12,000 image archive, weighing at least 3 competing explanations: micrometeoroid impacts, electrostatic discharge in lunar dust, and cosmic rays striking the astronauts' own eyes, without having confirmed which one, or which combination, actually produced what the crew saw. NASA's next moon missions, targeted for late 2027 and early 2028, will carry more human eyes back to that same unresolved question. If a story like this, real astronauts, real uncertainty, a genuine unanswered question sitting right at the edge of what we know, is the kind of thing you want more of, hit subscribe and turn on notifications, because I'll be covering Artemis III and whatever answer eventually comes out of this the moment it does. Here's the question for you. If you had to choose, would you trust a trained human eye or an automated camera to catch something nobody was expecting? Let me know in the comments. I read every single one.